to as skeletal muscle atrophy, we're referring to a neurological and physiological process that doesn't begin in the gym or even in the muscle tissue itself. It begins in the brain and is regulated through a series of downstream signals that affect protein synthesis, inflammation, mitochondrial function, and neuromuscular junction integrity. The question is, can a single vitamin influence this system? Can it prevent or reverse muscle loss in as little as 14 days? And if so, what is the underlying mechanism? Today, we'll explore the evidence behind a vitamin that does exactly that, vitamin D3. Vitamin D3 plays a critical role in muscle health by interacting with muscle cells at a molecular level, specifically through its action on the vitamin D receptor VDR. This receptor is present on muscle cells, and when activated by vitamin D3, it triggers a cascade of cellular responses that are essential for muscle maintenance, growth, and repair. The most significant of these responses is the stimulation of protein synthesis, which is the process through which muscle fibers repair and grow after strain or damage. When we engage in physical activity, particularly resistance training or any activity that involves load bearing, our muscle fibers experience microscopic tears. These tears are a normal part of muscle function, and the repair process is what leads to muscle growth over time. This repair process is governed by a complex interplay of signaling pathways, and vitamin D3 is a key player in this system. Upon activation of the VDR on muscle cells, vitamin D3 increases the expression of genes that are involved in protein synthesis, including the MTR pathway, which is known to be essential for cellular growth and muscle hypertrophy. The MTOR pathway helps control the rate of protein synthesis in response to various stimuli, including exercise, and vitamin D3 enhances this process, ensuring that the muscle fibers are adequately repaired and grow stronger after the stress. The role of vitamin D3 in muscle function extends beyond just protein synthesis. It also helps maintain the balance between muscle breakdown and muscle building. Under normal circumstances, muscle cells undergo a continuous process of catabolism, a breakdown, and anabolism, a building. When the body is deficient in vitamin D, the anabolic processes, those that build and repair tissue, are impaired, while the catabolic processes may be enhanced, leading to muscle degradation over time. This imbalance can result in muscle loss, particularly in older adults or individuals with limited physical activity. However, by supplementing with vitamin D3, the body can restore this balance, ensuring that muscle breakdown does not outpace muscle repair. In addition to the direct effects on muscle cells, vitamin D3 also plays a role in regulating calcium metabolism. Calcium is vital for muscle contraction and function, and vitamin D3 enhances the body's ability to absorb calcium from the diet and regulate its levels in the bloodstream. This calcium regulation is essential for muscle contraction and coordination. Adequate levels of vitamin D ensure that muscles can function properly, especially in tasks that require strength and precision, such as lifting or running. Without sufficient vitamin D, calcium regulation can be impaired, leading to muscle weakness, cramps, and reduced physical performance. Moreover, vitamin D3 helps improve muscle fiber recruitment. This means that when the body is under stress, during physical exertion, or even during recovery, vitamin D3 supports the nervous system in recruiting more muscle fibers for activity. This is particularly important during resistance training, as it allows individuals to recruit the maximum number of muscle fibers, enhancing strength and growth. The VDR in the brain and spinal cord also plays a role in this process, facilitating communication between the nervous system and muscles. Without vitamin D3, the nervous system's ability to effectively activate muscles can be diminished, leading to suboptimal performance and slower progress in strength training. Together, these mechanisms show how vitamin D3 not only aids in muscle repair and growth, but also supports optimal muscle function, coordination, and performance. For individuals experiencing muscle loss, whether due to aging, lack of activity, or other factors, replenishing vitamin D3 levels can be a critical factor in halting or even reversing muscle atrophy. It is clear that vitamin D3 is far more than just a nutrient that supports bone health. It is a vital component in maintaining and building muscle mass, strength, and overall physical function. Vitamin D3 plays a crucial role in neuromuscular function, and its impact on muscle health is directly connected to the function of the neuromuscular junction, which is the site where nerve cells communicate with muscle fibers. This junction is essential for the effective transmission of electrical signals from the nervous system to muscles, enabling movement. When we lack vitamin D3, this communication process becomes inefficient, leading to weaker muscle contractions, reduced coordination, and even muscle atrophy over time. The connection between vitamin D3 and neuromuscular health is facilitated through its influence on various pathways in both the nervous system and muscle tissue. One of the most significant roles of vitamin D3 in neuromuscular function is its ability to regulate the expression of genes involved in nerve growth and repair. Vitamin D3, when it binds to its receptor on nerve and muscle cells, modulates the production of proteins and enzymes that are necessary for the maintenance and regeneration of both muscles and nerves. The result is a ever more robust neuromuscular system that is better equipped to handle stress, recover from injury, and respond to physical activity. In the spinal cord, for example, vitamin D3 helps regulate the function of motor neurons, which are responsible for transmitting signals from the brain to muscles. Motor neurons rely on a steady supply of signals to communicate effectively with the muscles they innervate, but without adequate vitamin D3, these neurons can become less responsive, leading to reduced muscle strength and coordination. This is particularly noticeable in aging populations or individuals who have limited exposure to sunlight, as vitamin D3 deficiency is often linked to slower reaction times, poorer balance, and a higher risk of falls. The S-calcium signaling pathway is another way in which vitamin D3 influences neuromuscular function. Calcium ions play a pivotal role in muscle contraction. When a signal is sent from the nervous system, calcium is released within muscle fibers, enabling them to contract. Inadequate levels of vitamin D3 impair this calcium release, leading to weaker muscle contractions, cramps, and a diminished capacity for sustained physical activity. The ability to contract and relax muscles efficiently is essential not only for strength training, but also for everyday functions such as walking, lifting, and maintaining balance. Vitamin D3, therefore, plays a direct role in the efficiency of calcium signaling, which in turn impacts the functionality of the entire neuromuscular system. Additionally, vitamin D3 helps optimize the structure and function of the neuromuscular junction by influencing the synthesis and regulation of acetylcholine, the neurotransmitter responsible for muscle contraction. Acetylcholine is released by nerve cells and binds to receptors on the muscle fibers, triggering contraction. Vitamin D3 helps ensure that these acetylcholine receptors are in optimal condition, improving the efficiency of the neuromuscular junction and ensuring that muscles respond more effectively to neural input. Without sufficient vitamin D3, the number and functionality of these receptors can decrease, leading to weakened muscle contractions and reduced muscle function. The effects of vitamin D3 on neuromuscular health are particularly important for individuals who are at risk of muscle loss, such as older adults or those recovering from illness or injury. When vitamin D3 levels are optimized, the nervous system and muscle cells work more harmoniously, leading to better muscle strength, coordination, and a lower risk of injury. In essence, vitamin D3 serves as a key regulator of neuromuscular health, ensuring that the brain and muscles communicate effectively, leading to more powerful, coordinated, and functional movements. Vitamin D3 plays a crucial role in regulating inflammation within the body, and its impact on muscle health is profound. Chronic inflammation is a major contributor to muscle breakdown and loss. The presence of inflammatory cytokines such as TNF-alpha and IL-6 can inhibit muscle growth, repair, and regeneration. When inflammation remains elevated over extended periods, the body enters a catabolic state, meaning it begins to break down muscle tissue for energy instead of building or maintaining it. Inadequate vitamin D levels exacerbate this problem, as vitamin D3 is essential for modulating the immune system and reducing the production of these harmful inflammatory markers. One of the most notable effects of vitamin D3 is its ability to downregulate the activity of immune cells that produce pro-inflammatory cytokines. When vitamin D3 binds to its receptor, it helps to suppress the activation of immune cells like as macrophages and of T cells, which are responsible for generating inflammation in the body. This process reduces the release of cytokines such as TNF-alpha, IL-6, and IL-1, which are involved in both systemic inflammation that directly affects muscle tissue. By keeping inflammation in check, vitamin D3 helps to maintain a favorable environment for muscle growth and repair, and it prevents the chronic, low-grade inflammation that contributes to muscle wasting over time. Additionally, vitamin D3 impacts the production of myokines, which are signaling molecules released by muscle cells during exercise. Myokines have anti-inflammatory effects and help to promote muscle recovery and adaptation. The presence of adequate vitamin D3 supports the release of these beneficial molecules, improving the body's ability to respond to exercise and maintain muscle mass. When vitamin D3 is insufficient, the body's ability to produce these anti-inflammatory myokines is impaired, which can further hinder muscle repair and regeneration. Another key aspect of inflammation and muscle health is the role of oxidative stress. Oxidative stress occurs when there is an imbalance between free radicals and antioxidants in the body, leading to damage of cellular structures, including muscle fibers. Chronic oxidative stress has been linked to muscle fatigue, weakness, and the acceleration of muscle aging. Vitamin D3, through its effects on inflammation and immune modulation, helps to reduce oxidative stress. It supports the body's natural antioxidant defenses, including the production of enzymes like cyclosuperoxide dismutase and glutathione, which protect muscle cells from oxidative damage. By reducing oxidative stress, vitamin D3 not only preserves muscle tissue, but also enhances muscle function and overall metabolic health. In addition to its effects on inflammation, vitamin D3 has a role in the repair process following muscle damage. When muscles are exposed to stress, such as through exercise or injury, they undergo microtrauma, and the repair process involves an inflammatory response. However, when this inflammatory response is excessive, it can prolong recovery and delay muscle healing. Vitamin D3 accelerates muscle recovery by promoting muscle cell proliferation and differentiation, which is the process by which new muscle cells are created to replace damaged ones. It does this by interacting with the glia satellite cells found on muscle fibers, which are essential for muscle regeneration. This regenerative effect is particularly important for individuals who are recovering from injury or illness, as it helps prevent muscle atrophy and accelerates the restoration of muscle function. Chronic inflammation and oxidative stress contribute significantly to the loss of muscle mass, particularly in conditions like sarcopenia and eschscholtzia, which are commonly associated with aging and chronic diseases. Vitamin D3 has been shown to help mitigate the impact of these conditions by reducing systemic inflammation and promoting the repair of muscle tissue. By maintaining a balanced immune response and controlling oxidative stress, vitamin D3 provides an effective mechanism for preventing muscle loss and promoting long-term muscle health. The recommended dosage of vitamin D3 plays a significant role in how effectively it can support muscle health and prevent muscle loss. It's important to understand that the optimal dosage of vitamin D3 is not a one-size-fits-all solution. The amount required depends on a variety of factors, including a person's baseline vitamin D levels, age, body weight, geographic location, diet, and the amount of sunlight exposure they receive. Research consistently shows that vitamin D3 supplementation is highly effective at restoring deficiency in as little as 14 days, but for maximum benefit, the dosage needs to be carefully adjusted to meet individual needs. For most individuals, a daily intake of 2,000 to 5,000 IU of vitamin D3 is typically sufficient to restore optimal blood levels of 25-hydroxyvitamin D, which is the active form of vitamin D that the body uses. These levels are associated with improved muscle function, bone health, and immune regulation. This range of supplementation has been shown to be both safe and effective, even in people with low baseline vitamin D levels. However, the exact dosage required to achieve the desired benefits may depend on specific factors, such as serum vitamin D levels before supplementation, which can be measured through a simple blood test. For those who are extremely deficient, dosages may need to be higher initially to restore optimal levels, potentially up to 10,000 IU per day for a short period of time under medical supervision. One of the critical factors that affect the absorption and effectiveness of vitamin D3 is the presence of fat in the diet. Vitamin D is a fat-soluble vitamin, meaning it is better absorbed when taken with a meal that contains fat. This is an important consideration for anyone supplementing with vitamin D3. Taking it without food or with very low fat meals may significantly reduce its bioavailability. To optimize absorption, it's recommended to take vitamin D3 with a meal that contains healthy fats, such as those found in avocados, nuts, seeds, or olive oil. This simple practice ensures that the body is able to utilize the full potential of the vitamin D being consumed, supporting better muscle and overall health. Additionally, the effectiveness of vitamin D3 supplementation can be influenced by the presence of other micronutrients, particularly magnesium and vitamin K2. Magnesium plays a vital role in converting vitamin D into its active form in the body, and a deficiency in magnesium can impair vitamin D activation, leading to suboptimal results even with adequate vitamin D intake. Magnesium also helps regulate calcium levels in the body, which is crucial for muscle function and overall health. Similarly, vitamin K2 works synergistically with vitamin D3 to ensure that calcium is properly utilized in the body. While vitamin D helps absorb calcium, vitamin K2 directs calcium to the bones and away from soft tissues, where it can contribute to calcification. Therefore, taking vitamin D3 alongside these cofactors can enhance its effects, helping to maintain healthy bones, muscles, and overall metabolic function. It's also important to note that the body's ability to produce vitamin D through sunlight exposure can affect the need for supplementation. People living at higher latitudes or those who spend a significant amount of time indoors may have lower levels of vitamin D, especially during the winter months when sunlight exposure is limited. On the other hand, people who live in sunny regions or spend a lot of time outdoors may require lower levels of supplementation as they are able to produce sufficient vitamin D from direct sunlight. However, relying solely on sunlight for vitamin D production is not always practical or sufficient for everyone, especially for those with darker skin tones who require more sunlight to produce the same amount of vitamin D, or for individuals with limited sun exposure. In summary, the optimal dosage of vitamin D3 for preventing muscle loss and supporting overall health can vary, but a typical range of 2,000 to 5,000 IU per day is effective for most individuals. Adjustments may be needed based on individual factors, including baseline vitamin D levels, lifestyle, diet, and coexisting nutrient deficiencies. Combining vitamin D3 supplementation with healthy fats and other essential nutrients, such as magnesium and vitamin K2, will further enhance its effectiveness and ensure the body can make the most of this vital nutrient. Magnesium and vitamin K2 are essential cofactors for the proper metabolism and effectiveness of vitamin D3 in the body. While vitamin D3 plays a crucial role in muscle health, bone density, immune function, and a variety of other processes, its function cannot be optimized without these two nutrients. Magnesium, in particular, is involved in over 300 biochemical reactions in the body, including the conversion of vitamin D3 into its active form. Without sufficient magnesium, the body cannot activate vitamin D efficiently, which limits the nutrient's ability to support muscle function, calcium regulation, and overall health. Similarly, vitamin K2 plays a vital role in ensuring that calcium is properly utilized within the body. When vitamin D3 increases calcium absorption, vitamin K2 ensures that calcium is directed to the bones and teeth where it is needed rather than accumulating in soft tissues like blood vessels, which could lead to negative health consequences. Magnesium plays a crucial role in the activation of vitamin D3. When vitamin D3 is ingested, it is in its inactive form, and for it to exert its effects on muscle tissue, bone health, and immune function, it must be converted into its active form I-125-dihydroxyvitamin DV. This conversion occurs in the liver and kidneys, and magnesium is required as a cofactor for the enzymes responsible for this process. Without adequate magnesium, vitamin D cannot be properly activated, which means the body is unable to fully benefit from the muscle-preserving and bone-strengthening properties of vitamin D3. This is especially concerning for individuals with magnesium deficiency, as they may not experience the full positive effects of vitamin D supplementation, even if they take it regularly. Beyond its role in activating vitamin D3, magnesium also helps regulate the calcium balance in the body. Vitamin D3 increases calcium absorption from the intestines and encourages the body to retain calcium, which is essential for muscle function, nerve transmission, and bone health. However, too much calcium in the bloodstream can have harmful effects, such as calcification of soft tissues and arteries, leading to cardiovascular issues. This is where vitamin K2 comes into play. Vitamin K2 works synergistically with vitamin D3 to ensure that calcium is properly utilized and directed to the right places in the body. It activates proteins like osteocalcin, which binds calcium to bone tissue, and S-matrix GLA protein, which helps to prevent the accumulation of calcium in arteries and soft tissues. In essence, vitamin K2 ensures that calcium works in harmony with vitamin D3, keeping it in the bones and away from places where it could cause harm. The combined effects of magnesium and vitamin K2 with vitamin D3 are especially important for maintaining muscle mass and preventing muscle loss, particularly in aging populations or those at risk of deficiency. Aging is often accompanied by a natural decline in both vitamin D and magnesium levels, as well as a decrease in bone mineral density and muscle mass. This can lead to conditions like sarcopenia, muscle wasting, and osteoporosis, bone thinning. Without sufficient magnesium, vitamin D3 may not effectively support muscle maintenance, and without adequate vitamin K2, calcium may not be properly directed to bones, increasing the risk of fractures and bone loss. The interplay between these nutrients is essential for supporting both bone and muscle health, making it important to ensure all three, vitamin D3, magnesium, and vitamin K2, are sufficiently available in the body. Deficiencies in any of these nutrients, vitamin D3, magnesium, or vitamin K2, can compromise the body's ability to maintain optimal muscle mass and function. For example, magnesium deficiency can lead to muscle cramps, spasms, and weakness, while a lack of vitamin K2 may contribute to arterial calcification and impaired bone health. Therefore, it is crucial to not only focus on adequate vitamin D3 intake, but also ensure that magnesium and vitamin K2 are included in one's diet or supplementation regimen to maximize the benefits of vitamin D. Ensuring a balance of these nutrients can help prevent muscle loss, improve bone health, and support overall vitality. Muscle preservation and overall physical resilience are not solely dependent on exercise or dietary protein intake. One of the most significant factors that support both muscle health and overall metabolic function is the proper regulation of vitamin D3 levels. Beyond its well-known role in bone health, vitamin D3 plays a crucial role in maintaining muscle mass, strength, and function, particularly as individuals age. Research shows that sufficient vitamin D3 levels contribute to an enhanced immune system, better others' muscle function, and improved others' physical resilience, all of which play a direct role in a person's ability to withstand the stresses of daily life, as well as more demanding physical challenges. When vitamin D3 is present at optimal levels, it helps regulate the balance between muscle catabolism, breakdown, and anabolism, growth. Inadequate levels of vitamin D3 shift this balance toward more catabolic processes, where muscle breakdown exceeds muscle repair and regeneration. This is particularly concerning for aging individuals who naturally experience a decline in muscle mass and strength over time, a condition known as sarcopenia. Vitamin D3 helps to combat this by promoting muscle protein synthesis and reducing inflammation that contributes to muscle degradation. With optimal levels of vitamin D3, the body is better equipped to repair and build muscle tissue, leading to improved muscle preservation and reduced risk of muscle loss as a result of age or inactivity. In addition to its role in muscle preservation, vitamin D3 also supports neuromuscular function, which is essential for maintaining physical resilience. Vitamin D3 influences the health and function of motor neurons, which are the cells responsible for transmitting signals from the brain to the muscles. These signals are crucial for coordinating movement, maintaining balance, and executing strength-related tasks. Without adequate vitamin D3, the efficiency of motor neuron signaling can be compromised, leading to weakness, reduced coordination, and an increased risk of falls, particularly in older adults. By supporting motor neuron health, vitamin D3 ensures that the nervous system and muscles can communicate effectively, leading to more coordinated and controlled movements, as well as better physical performance. Furthermore, vitamin D3 plays a crucial role in regulating the immune system, which is intimately connected to muscle health and overall resilience. When the body is under stress, whether from physical exertion, illness, or injury, its immune system activates to protect and repair tissues. However, chronic inflammation, which can result from an overactive or imbalanced immune response, contributes to muscle breakdown and delays. Vitamin D3 helps to regulate this immune response, ensuring that inflammation does not become chronic and that the body remains in an optimal state for healing and muscle recovery. By reducing Rs pro-inflammatory cytokines and promoting the production of anti-inflammatory proteins, vitamin D3 supports an environment that fosters muscle repair and growth, rather than one that accelerates muscle breakdown. Muscle preservation is not only important for maintaining strength and mobility, it is also directly tied to overall metabolic health. Muscle mass plays a significant role in glucose metabolism and insulin sensitivity, both of which are essential for maintaining healthy blood sugar levels and preventing metabolic conditions like type 2 diabetes. Vitamin D3 has been shown to enhance insulin sensitivity, helping to regulate blood sugar levels and reduce the risk of metabolic dysfunction. The preservation of muscle mass, particularly in aging individuals, is directly linked to improved metabolic outcomes, as muscle tissue plays an essential role in energy, expenditure, fat metabolism, and overall metabolic rate. Additionally, adequate levels of vitamin D3 enhance physical resilience by improving bone density and strength. Bone health and muscle health are closely intertwined, as strong muscles help protect the skeleton from injury, while strong bones provide a stable base for muscle function. Vitamin D3 promotes calcium absorption and bone mineralization, which is essential for maintaining bone density and preventing conditions like osteoporosis. This is especially important for older adults who are more prone to bone fractures and other injuries due to a combination of declining bone density and muscle mass. By supporting both bone and muscle health, vitamin D3 contributes to overall physical resilience, helping individuals stay active and maintain their independence as they age. In conclusion, maintaining optimal vitamin D3 levels is essential for preserving muscle mass, improving neuromuscular function, and supporting overall physical resilience. By promoting muscle growth and repair, reducing inflammation, enhancing immune function, and supporting bone health, vitamin D3 helps the body withstand the challenges of physical exertion, aging, and injury. Its role in preserving muscle mass and strength is especially crucial as individuals age, ensuring that they can maintain an active and independent lifestyle for as long as possible.